Today we're going to take a look at binomial probability. So here's some criteria for binomial probability. Each trial has two outcomes, fixed number of trials, outcomes are independent, and probabilities are consistent. So if we take a look at this one, a basketball player makes free throws 2/3 of the time. What is the probability he will make 4 out of 5? So there's two outcomes. He makes it or misses it. There's fixed number of trials. There's 5. Outcomes are independent. One doesn't vary on the other. Shot doesn't vary. And the probability is always 2/3. So let's think about this. If you're going to make 5 shots and you make 4 out of 5, you could make, or miss. And you could have a couple different orders of that. Make, miss, and make. And where else could we do that? Make, miss, make. Make, miss, make. Or you could miss, make, and make. And so these probabilities, there's 5 different ways that you could make 4 out of 5. Well, this probability is 2/3 that you make it and 1/3 that you miss. So we have 2/3 to the 4th power times 1/3 to the 1st. Well, this one's the same way. There's 4 multiplying 2/3 4 times and 1/3 1 time. So you guys will notice this is similar to the expansion that we did before. Our exponents add up to something, and then we have that number out in front. There's 5 times. So there were 5 different ways of that probability of 2/3 to the 4th power, making it 4 times, and missing it once. Now the cool thing is our calculator can do this for us by just identifying a couple things. So if we take a look at number 2, if cared for properly, a tree has a survival rate of 90%. If 10 trees are planted, what is the probability that 7 will survive? So if we can identify some things, our trials, how many trees are there? There's 10. And what is the probability of success? Well, its probability is 90%. And how many do we want to survive? We want 7 to survive. So our calculator does all of this for us. If we hit functions and go down to binomial distribution, it says trials and success probability. So there's 10 trials. Our success was 90. And if we do this cumulative, it says min and max, but we want 7 each time. So 0.057, so 5.7% chance. So this next one, if 8 out of 10 people will recover from a certain virus, in a group of 7 people who are infected, what is the probability that 3 people will recover? So trials, how many people are we looking at is 7. We want to not recover. So our probability of success, what is not recovering? Well, 2 out of 10, or we could say 0.2. And what do we want? We want 3 people to not recover. So we could go back here. So we have 7, and we said 2/10. And then we can change this to what we want is 3. So 11.5%. And then this last one, what is the probability at least 5 people recover? So our trials, again, there's still 7 people. The probability of success, we want people to recover, so that's 8 out of 10. And then what do we want? At least 5 or more, because we want at least 5 people. So the only thing that changes back here is we want this to be 8 out of 10. And if we want 5 or more, that means 5 all the way up to the 7 people to recover. So 5, 6, or 7. So our min is 5, our max is 7. So we have 85.2%. And we could look at more examples like this as well. But I'm going to have you guys start your Delta Math assignment and then let me know if you have any questions.